Hey guys, Smarty here. From the channel Smartest Stranger. In this video, we are going to be looking at what is automation or industrial automation, levels of automation, types of automation, advantages and disadvantages of industrial automation, uses/applications of automation, industrial automation tools. Example to understand industrial automation. What is automation or industrial automation? Automation is a method of controlling a process by automatic means. Or we can say that automation is the technique of making a process or a system operate automatically. The automated system needs special dedicated hardware and software products for implementing control and monitoring systems. In recent years, the number of such products has been developed from various vendors which providing their specializing software and hardware products. Some of these vendors are Siemens, ABB, UB, National Instruments, Omron, and so on. Automation covers applications ranging from a household thermostat controlling a boiler, to a large industrial control system with tens of thousands of input and output control signals. In control complexity, it can range from simple on-off control to multivariable high-level algorithms. There are two types of control loop: open-loop controller, closed-loop controller. In open-loop control, the control action from the controller is independent of the process output. A good example of this is a central heating boiler controlled only by a timer, so that heat is applied for a constant time, regardless of the temperature of the building. In closed-loop control, the control action from the controller is dependent on the process output. In the case of the boiler analogy, this would include a temperature sensor to monitor the building temperature, and thereby feed a signal back to the controller to ensure it maintains the building at the temperature set on the thermostat. For this reason, closed-loop controllers are also called feedback controllers. Levels of automation. The figure shows the process automation system hierarchy. Machinery/plant level. This level consists of machines which are closest to processes. In this, sensors and actuators are used to translate the signals from the machines and physical variables for the purpose of analysis and to produce the control signals. Direct process control. In this level, automatic controllers and monitoring systems acquire the process information from sensors and correspondingly drives the actuator systems. Some of the tasks of this level are data acquisition, plant monitoring, open and closed loop control, reporting, plant supervisory control/shop floor level. This level commands the automatic controllers by setting the targets or set points. It looks after the control equipment for optimal process control. Some of the tasks of this level are plant monitoring performance, optimal process control, plant coordination, failure detection, production scheduling and control/plant level. This level solves the decision-making problems like resource allocation, production target, maintenance management, and so on. Tasks of this level include production dispatch, inventory control, production supervision, production reporting, etc. Plant management/enterprise level. This is the higher level of the process plant automation. It deals more with commercial activities than technical activities. Tasks of this level include market and customer analysis, Orders and sales statistics. Production planning. Capacity and order balance, etc. Types of automation. There are 4 types of industrial automation. Soft automation. Hard automation. Programmed automation. Integrated automation. Soft automation. Soft automation involves entering new code on systems you own. These are almost always controlled by computers and are useful when the result changes frequently. For example, CNC machines must be programmed for each new job. Once the operator programs the code, the machine then produces the part. Hard automation. Hard automation is fixed and is very difficult to change once production begins. The equipment is programmed with an essentially permanent set of tasks. This type of industrial automation is popular in continuous flow processes, such as mass production and conveyors. Programmed automation. This type of industrial automation requires a set of programs or configurations that can be set with electronic controls. Although it is more flexible than hard automation, programmed automation is still time-consuming and best used on high-quantity production lines for large batch production. Integrated automation. An integrated automation system pulls together standalone machines, data, and processes to work together following a single control system. For example, computer-aided design, computer-controlled machines, robots, and conveyors may all be integrated to complete a larger task, following commands of a scheduling control system. Advantages and disadvantages of industrial automation. Advantages of industrial automation. Manufacturers face many challenges in today's globally. Some of these challenges include harsh manufacturing environments, increasingly complex supply chains, meeting the latest energy-efficient standards, and competing with companies with very small marginal costs. Many of these reasons drive manufacturers towards industrial automation. The advantages to industrial automation include increased labor productivity, improved product quality, reduced labor or production cost, reduced routine manual tasks, improved safety, assisted remove monitoring, efficient use of raw materials, reduce energy consumption, increase business profits. The disadvantages to industrial automation include loss of jobs. Since majority of the work is done by machines, the requirement for manual labor is very less. All the desired tasks cannot be automated. The initial cost of an automation system is very high. Skilled persons require for maintenance and service. Maintenance. Incompatible with customization. Dependency on technology. More pollution. Uses of automation. Many industries are using industrial automation processes nowadays. Some of the largest ones includes manufacturing, paper mills, distribution, automated laboratory instrument, automated restaurant, mining, waste management, network automation, home automation, air conditioner, geyser, and etc. Building automation, automatic door, elevators, fire alarms, parking, steel mills. Transportation. Automated power production. Food and drink. Construction. Cement industry. Industrial automation tools. A wide range of tools are required for industrial automation. They include various control systems, different devices, and systems impacting aspects of the manufacturing process. The key tools are Programmable Logic Controller, PLC. A PLC is a digital industrial computer control system that is used to carry out automatic operations in industrial processes. The PLC continuously monitors and receives information from input devices, processes the information, and triggers the connected output devices, to complete the task in the industrial process. Supervisory Control and Data Acquisition, SCADA. SCADA systems control and monitor industrial processes. The system acquires and processes real-time data through direct interaction with devices, such as sensors and PLCs, and records events into a log file. Human-machine interface, HMI. An HMI enables communication between a human and the machine. It translates complex data into accessible information, enabling better control of the production process. Neural network, NN. It is a computing system that is built like the human brain, a network of interconnected neuron nodes, and simulate the way a human brain analyzes and processes information. Distributed Control System, DCS. A DCS is a central monitoring system that interconnects devices to control different elements within an automated system. RPA, Robotic Process Automation. Robots can efficiently perform tasks in complicated or dangerous situations, improve production flow and quality, and increase safety for employees. Example to understand industrial automation. Consider an example. An operator is observing the temperature of an oven, and the task is to reach a certain temperature and maintain that temperature for about 15 minutes. So, the operator has to first adjust the amount of fuel to the oven by controlling a valve to rise the temperature to the desired amount. Once the necessary temperature is achieved, it has to be maintained by constantly adjusting the valve. Either increase or decrease the fuel depending on the temperature for the next 15 minutes. Now, in industrial automation, the whole process is taken care of without the help of an operator. First, there is a temperature sensor placed near the oven which reports the temperature to a computer. Now, there is motorized valve or actuator, which is also controlled by the computer, for the fuel to be supplied to the oven. Based on the value of temperature readings from the sensor, the computer will open the valve to allow more fuel in the beginning. Once the desired temperature is achieved, the valve is shut off. But the computer can open or close the valve, even to allow a small amount of fuel to flow, based on the temperature readings. The timer in the computer will indicate once 15 minutes is up and the computer can completely shut off the system. So guys, this is a basic overview of industrial automation. For more informative videos, follow us on YouTube. Thanks for watching.